Good morning everyone, welcome to this Advanced Steel webinar where I'm going to be showing you some modelling tips and tricks while we're creating a play park within Advanced Steel. So for those of you who haven't met me, most of you will have done by now. My name's Rob Merriman. I've only ever worked in the construction industry. I started off as an architectural metalwork draftsman and then moved into being a structural steelwork draftsman, both using Advanced Steel. So when I was working in industry, it was within two subcontract drawing offices, so I've worked across multiple projects with lots of different fabricators. I currently work as a structures application engineer for Graitec UK, so I provide training, technical support, customization for structural CAD packages, mainly focused on Advanced Steel, but we also look after AutoCAD, Revit, Navisworks, Recap, and Fusion 360. Anything to do with structures and the AEC collection for you guys. So a quick little bit about Graitec. We are a global company and we are technically driven. The majority of our staff are technical staff. We are 30 years old. Headquarters are based out in France and we work throughout 11 countries worldwide. We are becoming one of the biggest Autodesk partners worldwide. Like I said, we are technically driven, so we do have our own technical team out in Romania who develop our Graitec products. So our Graitec products like Advanced Design or Advanced Workshop and the Power Packs. And then we're here to help and work with you guys. So Graitec is one of the only companies that can take your project from start to finish, and we've broken that down into 4 key areas. So that is create, simulate, fabricate, and manage. So create is using the Autodesk products and enhancing them with the Graitec Power Packs. Simulate is then taking that model and checking that it can withstand the real world environment. So we have Advanced Design and Advanced Design Connection within the simulate area. Then we need to fabricate, so that is obviously where Advanced Steel sits in, but we do also have products like Armor Plus and Advanced Workshop to look after your actual workshop and the processing of the steelwork within your workshop. And then finally we have Graitec Manage. So all of the other areas produce documents and data and work in progress data, and these days you've got to collaborate with an external common data environment. And if you're working on 8 projects for 8 different main contractors, you might have 8 different external common data environments. We have Graitec OpenTree that will manage all of that for you within the one platform. So this webinar today is being recorded. With all of our webinars, whether they're the dedicated Advanced Steel ones or the AEC ones, so looking at other tools within the AEC collection, all of our recorded webinars go up onto our content portals. There is an Advanced Steel dedicated one. We're up to about, I think, 50 hours now of recordings up on the content portal, so you can watch them on demand. Do you get our blogs? Either just the Graitec ones or the dedicated Advanced Steel ones. Myself and Alec try and put out about 1 blog a month. So if you click on the links in the handout, you will be able to click on the link and then subscribe to the Advanced Steel blog so you don't miss any Advanced Steel tips and tricks. If you are a Graitec customer, you can watch the BIM Up 2019 and BIM Up 2020 conferences. So those were 3-day online conferences that we ran. The 2021, we ended up running over 270 classes over 3 days and in 7 different languages. So they are now up on the Advantage site. And the Advantage site is where you get your Power Packs from. And if you are, I'm talking to the sort of UK customers here, other countries just check with your Graitec office. But if you're a Graitec UK supported customer, you should have access to the Power Packs. If you don't have it installed and you don't know what it can do for you, please reach out to me and we can run through it. I have attached the Power Pack flyer in the handout section of this webinar. So the upcoming webinars for this quarter, next week, yeah, that is next week. I'm going to be looking at the Revit and Advanced Steel workflows. We'll do We'll look at workflows for structural, architectural. I might even attempt to get this play park sent into Revit. We'll see how that goes. And then Alec, the week after, is doing an advanced deal frequently asked questions, some more tips and tricks, the questions we get commonly asked on technical support. So you can click on those links and register for them. And then in the next quarter, so when we head into January, we'll launch a new set of webinars. So keep an eye on our social media, or click on the link there, which will take you to our events page. So today we're going to look at two areas of a play park. Now, I've got two young kids, so I spend most of my weekends out and about and taking them to different play parks. And because I've only done steelwork since I left university, I end up looking at the play parks going, oh, that's all just steelwork. So we're going to model a roundabout. So we're going to look at the beam from line command, we can look at transform elements, polygon plates and gratings, the UCS commands that we can use, and then special parts. So today is sort of bringing together lots of different tips and tricks for modeling. So although I'm doing a play park, hopefully you'll be able to apply it to what you guys do day in, day out. Then we'll look at some railings within the play park. So we're going to look at modeling these manually because they don't have a top rail and they've got a hooped bar in them. So the railing macros are not going to do that for us. So we're going to look at how to split the beams, custom connection building blocks and what we can do with them, and then creating and using some different custom connections. So the roundabout. Like I said, when I'm sat there in the park and the kids are charging around, I'm looking at all of these things they're climbing on going, well, that's just tubes and plates and bolts and welds and connections. So when you break it down, they are just steel members bolted and welded together. So that is the roundabout from the play park near my house, and that is what I'm going to roughly be creating today. And when you break it down, it's not a huge amount different to that. Yes, it's got curved items in it, but it's still got some gratings in there. The Durbar is a grating. It's still got beams, and it's still got some special parts. So there are lots of curved items in there, so we're going to use the beam from line command to do that. So there is going to be some 2D AutoCAD work in here. Items that you're putting into a tube bending machine, we're going to model as beams from polylines. And one sort of key rule when you're modeling in advanced steel, and people say, well, how would you model this and how would you model that? I will always say, well, how are you making it? So go and speak to your workshops, go and speak to the guys making it, find out how they're going to make that, and then you model it in the same way. Any bought-in items then need to be modeled as a special part. So let's go and have a look at putting some of this into practice.
Okay, so we're going to start a new template file. We're using a custom Graitec template there. Alec has done a webinar previously on custom template files, and there's quite a few webinars out there. Quite a few blogs out there that Alec has done on custom templates as well. So we're going to start with the roundabout. So we're going to put a central column in. Now this roundabout isn't going to be perfect. I've only got 40 minutes to show you quite a few tips and tricks. So we're just going to start with our central column, and we'll put a tube base plate on there. So we'll say that it's circular. It's going to be 15 mil thick, and we're going to make this, let's say 400. We'll put some resin anchors in there, and we'll put that, we'll do total, and we'll make that 200 to 50, and we'll say that we want 5 bolts in there. That'll do. We're going to put a cap plate on. So there is in the connection vault an end plate macro, so we can choose the top of the column. We can shorten by the plate thickness, and we'll make that, we'll make it a 10 mil one, and again we can make that round, and we can make that flush or round, or we can just say it's an 8 mil fillet weld. Now what I'm going to do is I'm just going to move my UCS up 150mm because this is where, so that is my central spine. Then we're going to have the whole thing just for ease of today's session slide over the top. So we're going to make this 1375 and we will go for the 114 by 6, so that'll just slide over the top. Maybe we need a slightly smaller wall thickness. We'll go 3.6, that gives us a bit of a gap. In fact, we'll go 5. Okay, so we're going to be working now on the actual roundabout. So I'm going to, with everything, I'm going to put some construction in. We're going to have an outer diameter of, let's say, 1500. It's a little bit big actually. Let's do 1200. And then I want a couple of lines at the quadrant, and then what I'm going to do is I'm just going to rotate this line. Just turn my endpoint snap off from the node, and we're going to go 60 degrees. No, we're not, we're going to go minus 60 degrees. In fact, we're going to go minus. Wrong command. We'll get there in the end. We're going to go minus 30. So that's where I want. That's going to be one of my arms. Now, for the tube, I'll be honest, I'm not exactly sure whether it will be made from one piece or two pieces, but I'm going to make mine from one piece like that, and then we'll rotate it round. So I'm going to use the beam from line command. We're going to use that quite a lot today, so we're going to choose that line in there. Do I want to delete the objects? We'll say yes. We'll position that in the middle, and we'll call this a curved beam. We will then do the beam from line again on this one. We'll delete that line, and this one is going to be a T section. We'll just do something a little bit different in here. So we'll choose T in here. That looks okay to me. That gives me a decent flange to work with as well. And we'll put the system line in the middle. We'll move it up in a second, and we will just call this a beam. Okay, so the first thing we need to do is move this up 57.15 because the outer tube is a 114.3. And then we probably need to drop this down as well a little bit. We'll drop it down 50, that'll be fine. So now we need to cut this T section against both of these. So I'm going to use the element contour with a rule. So the object to be modified is this one here. This is the object to cut to. That will put the notch on. We'll put a mil gap around it to give our workshop a fighting chance of getting this fitted. And then we can joint copy that. So this is the beam to be modified. This is the beam we're cutting to. See what it didn't like in there. So we've got this create shortening tick. So that's, if I untick that, that will just take that shortening off. So we can just, what we'll do is we'll just do quick class check in here. We've got no errors. we'll also just check what's welded. So you can see in there that's welded on the outer. We don't want that welded to the inner tube, but if we check what's attached on the inner tube, so for that I'm using clear marking and display objects connected in shop. So anytime you're doing this kind of stuff, it's always best to do these checks as you're going along and as you're modeling. So what we'll do now is I'm just going to rotate this 180 degrees. We'll do a preview. What didn't I do there? I didn't select a rotation point. So I'll choose a node in there. Do my rotation point. That time I didn't put the angle in, so hopefully this time we've got that, so we can say okay with that. And then I'm going to polar array this item in here. So I've chosen angle to fill and the angle between the items. So my angle to fill is 360 degrees. The angle between the item is 100 degrees. Now that's only selected one item. If I want to copy everything, I can say include additional connections. Try and get in the habit of doing a preview so you can see what it's going to do, and then we can click OK. Just going to move my UCS up to the node in here, and we're going to draw a new circle at 1200, and we're going to draw in a couple of lines in here. So now what we want to do, we need an inner circle as well from there. That we'll do 60, yeah, that's fine. So I want to see my construction line, so I'm actually just going to use the filter in here to select all the advanced steel objects, and then we're going to turn those off. And then I'm just going to use my trim command just to tidy that up. And then I'm going to join those into a polyline. So that's a polyline. We can turn everything back on. And then what we'll do is we'll come to I'm going to make this out of Durbar. So I'm going to use a grating, and I'm going to use grating at polyline. So if I can't select it because it won't let me, I'll do a selection window from right to left. That will select everything within the window, and then deselect the beam. And then that will put my grating on, and I've set it to EU checker plate, and it's a 10 by 12. So the overall thickness is 12. The plate is 10, so we've got a 2mm bulb on there. Now what I'm also going to do in here, that is sort of tight on the center line, so I've got no gap in there. So I could have offset my polyline and messed about with the polyline, but there is actually a tool in Advanced Steel where you can shrink or expand a poly plate. Because this is a poly grating, the command will still work on it. So we choose the plate, grating in this case, and then we just type our value in with a plus or a minus. So if I say -2, and we go and have a look at the top, you can see now that shrunk in 2mm all round. So that will work on beams, plates, and gratings. Next we need to put some bolts. I'm just going to bolt to the center. I don't have enough time to fully do this. I'm just trying to whiz through some different tips and tricks for you. So what we can do is we can do UCS at object. And if we do UCS at object, you'll see that we've got all these little lines coming up here. Now this is where the system will put your UCS onto the object and align it with the edge. You can see when I click this one, the long line is the Z-axis, the second longest line is the X-axis, and then the shortest line is the Y-axis. So if I do that, that will put my UCS on that edge. I can then move it to the midpoint, in there, and then I'm going to move it in 30mm, let's say, and we'll put our bolts in. So I'm going to bolt through this and this. We'll get the distances sorted first. So in the Y direction I want 1, in the X let's say 200 centres, 300 centres, 4 bolts. Creep that out a little bit, that looks good, 350. Now we obviously don't want the kids falling over, so we don't want them as XOXs. Now if I choose countersunk, I can only go down to M10, which in this example is probably going to be okay. One question we get asked a lot on technical support is, can we have smaller countersunks? Well, actually, there are already smaller countersunks in the system. It's the EN ISO 10642. Those are countersunks that will let you go down to M6 or M8. So they are already in the system. They're just listed under a different bolt type. Now what we'll do, we'll come back in here and we'll use our polar array again, and this time we'll say total number of items and angle between the items. So I only want one item because I'm going to array these bolts. We'll do a preview on that, and that is what I haven't done is set my UCS back to world. So that's why we do a preview. So we'll cancel out of that completely. That was me being naughty and I didn't set my UCS back to world. So we'll do a polar array. We'll do a preview on that. So that's gone the opposite direction. And now what it's saying is, well, I was connected to this grating. There's no grating over here. So we can just cancel that, go back in, and we'll say actually it's minus 120 mil. And that's gone to the wrong side anyway, because that was going to do that. So, okay, we will just do it a different way then. We'll put our UCS onto this edge in here. We'll move it to the midpoint on the edge in here, and we'll just spin ourselves around, move ourselves the same distance, which is 30 mil. Now what Advanced Steel will do is it will remember the last bolts that I created, so it will put them in there. Now, little tip for you, if you want the system to remember certain things, you right click on the dialog in here, and this is where you can tell it what to remember. So everything that's ticked in here is what the system is remembering. So if you don't want it to remember the bolt type or the grade and use the standard ones, you can untick these. And the same works with beams. If we're modeling beams, if I set the material grade to 355 JR and the coating to black, when I model the next beam, you'll see it's remembered those, because if we right click in there, it's remembering the material and the coating. And you do have in here different tabs, so it's remembering the positioning. You can get it to, it's not remembering anything in here, so you can get the system to remember more and more things for you. Okay, so now we have our grating. We'll just set the display type to standard. Now we can just finish this and do our final polar array. We'll go back to total number of items, no, angle to fill is going to be 360. No, sorry, I want that one. So we're going to select this. I want 2 items. UCS has not been set back to world. That's the only thing with manipulating your UCS, is you've got to remember to put it back. We will do a preview. Okay, so when we're arraying, and it's the same with AutoCAD, you always put in one more than you actually want. And then that is the basis for our roundabout. Now, what we're going to do next is actually put the roundabout in the park that I take my kids to. Has got some little motorbikes on it, so we're going to create a couple of little motorbikes, and then the handles here. Okay, so for the little motorbikes, it's going to be fairly straightforward. What we're going to do, we're going to use the UCS object, but this time on the little T sections, because I do actually want it in the middle of the T. So we're just going to rotate round, so our XY is pointing that way. We have a little tube section, so we'll add a little tube in there. Let's just go 400. We'll make it a little bit smaller, need to be very big, something like that. That looks okay. And then what we're going to do is we're going to do a little bit of construction. We're just going to isolate the beam we're working on. So we're going to have a little seat in here. Now I'm going to do some 2D construction. So I've rotated my UCS. What I want to do is use this little icon here, turn 2D snaps on or off. Because now wherever I click, even if I click the end point in here, it's going to lock that on the center of my tube, so on my XY plane. So it just makes 2D drafting so much easier. So we're just going to bring this down 35 mil. We'll bring it out, let's say 200. I might be getting my proportions way off, but you sort of get the gist of what I'm doing in here. I'm just going to push and hold my and we'll bring that back ever so slightly there. And then what we're going to do is we're going to do a fillet, and we're going to set the radius to 50 mil. Because this is a pipe that we're going to be putting into our bending machine. And then we're going to trim this away to here. Now that is not a poly beam at the moment, so what we're going to do is we'll join these together. And if we look at the properties, that is now a polyline. So I'm going to move my UCS to the endpoint up here. And we'll spin ourselves around a little bit. We'll spin ourselves around that way. And now what I'm going to do is I want to rotate myself around the x-axis. So I'm going to type the word x, and I'm going to say -30. I wanted to go the other way. So UCS x 30. That'll drop me that way, and then I can come on to the top here. And we're just going to do let's say 175. We'll go 100 that way and 100 that way. Because then I can do a 3-point arc from the end to the end to the end point. And get rid of those. And now I've got the basis of my handlebars and my motorbike. Not quite right, I don't think. So let's bring you out another 100. And move you from the quadrant to the end point. Turn my 2D snaps off, and we'll just set the UCS back to world. And now I can go back to that beam from line for the top one. Now we'll make this a 42 mil tube, I think. Maybe even a little bit smaller, 33 let's say. And again, that's going to want to be a curved beam. Now this one in here, if I did beam from line, what it would do is it would give me the individual pieces. So if we were welding this pipe up, that's what we would do. But we're not going to be welding it. We want to put it in the bending machine, the tube bending machine. So I'm going to use beam from polyline. So if we do P for polyline, delete the source objects, we'll say no. That now creates a poly beam for me. So that's one item that's going into the pipe bending machine. We'll repeat our element contour rule. So this is the item to be modified. This is the object to cut to. Doesn't like it, probably because it's a poly beam. So this is the one to be modified. This is the one to cut to. We'll have to do it the manual way. I've not drawn it long enough, that's why. Now in here, we might end up sort of crushing the end of this and just welding it. There's no real way of doing that in advanced steel. So we would just have to do the element contour UCS and do that, and maybe put a note on the drawing. Just going to go back quickly to this bit in here, UCS on the top. Go to a top view, and again I'm just going to lock myself in 2D, and we'll just come down here 85, 60, 140, 25 that should have been, 50 mil there, and we'll finish that line there. What we'll do is we'll just use the AutoCAD mirror commands just tidy this up, and then we'll put some fillets on it. Yeah, we'll do a 50 mil on the back. R for radius, change these ones to 10. We need to go endpoint to endpoint, do our fillets again. And then we can join all of those together. Not the tube, so if you want to deselect, push and hold the shift command, that will deselect. And then we can do instead of grating at polyline like we did earlier, we can do plate at polyline. So we can say that's 10 mil, that'll do. Proportions are a little bit off, but you get the general idea. Now if this is just going to be welded up and your workshop know what we're doing, we could just weld everything up based on that point, just so it's all attached in the workshop. Proportions aren't too bad actually. We'll set our UCS back to world. We'll do our polar array. I know I would have to create some kind of base and weld that. Do a preview. That looks good. Okay, so the last little bit we're going to do is the end caps in here. Now, a lot of the time in parks and things like that, we've got sort of domes and bought-in items, so we can still put those in as special parts. So what we need to do is start a new drawing. We're going to create these as special parts. Now your supplier might have a 3D solid of it, but these are just spheres basically that are going to be either welded or glued in, or sometimes they're just banging end caps So however you create them is up to you. They just need to be a 3D solid. I have done a webinar on special parts. So I'm just going to do a dome sphere to go on the top of our big tube. So the diameter, we'll change that to D for diameter, and that's going to be 114.3. So pretty small. But I only want half the sphere, so I'm just going to draw in here, and I'm going to say, right, come back 50 mil. That'll do. Oh, that's not enough, but it will be in a second. Because we're just going to subtract this. So then I will extrude this, I don't know, 200 mil. We'll just move it back this way 100. And then I'm going to do a subtract. So I'm going to subtract from the sphere this shape, and that gives me my sphere in there. Set my UCS back to world, and we'll save that as diameter 114.3 semi-sphere. So that's that one done. For the 33 mil tube, we're going to do a little bang-in end cap. So again, I haven't saved this. We've done 25 minutes of work and I haven't saved it. Sorry, Advanced Steel Play Park. So the other one is going to be a bang-in end cap. So that's just going to be a 3 mil end cap. And it's going to be a plastic one. The sphere is going to be a steel one. So for the end cap, we'll just draw the shape that we want. So we want, let's say it's 5 mil. That's going to be down 5 mil. We could just do it as an actual disc. I think I did that as 4 mil thick wall, so we'll say it's 4 mil thick. And what we'll do, we'll bring it down 6 mil. We'll take it back to that point there. We'll see what's going to happen in a minute. So I'm drawing half the shape. Oh, did not want to do that. So we'll join all of those, set the UCS back to world, and then we can just do a revolve. And we're going to revolve from that point 360 degrees. And that is going to be my bang-in end cap. Now, if you had a catalogue number, you could save it with the catalogue number. And then once we've got those created as special parts, we can just put them into our model. So first thing we're going to do is that sphere. So we're going to put our UCS there. We'll go insert special part at the 0 point. Go and look for our special part, which is on my desktop. And that'll put my sphere in, so then we can set the material grade, the coating. We'll give it a name, we'll just call it ACES Solids. And then for the UK at least, I'm going to copy the free remark to the commodity number, because that's what we'll show on our material list. And then we can weld it to our column based on that point. Now for these bang-in end caps, I should have probably put them in beforehand. I need to get my UCS on the end of this tube. So what we're going to use is we're going to use, in our UCS tab, there is a command, UCS at curved beam. So we'll choose a curved beam, hit enter. Oh, maybe I need to be in the 2D wireframe. that's now put my UCS. I needed to do the second point. That's now put my UCS on the end there. We can then come in and put our special part in. So we'll do the banging end cap. My Z-axis was pointing the wrong way because the Z-axis in the special part was coming up in the positive Z, so that's where it should be when we put our special part in. So we'll just do that again. Now I don't have to go and find it because it's already been defined in the model. That will just put it in and put it in on the end there. So I should have done both of those before I arrayed it round. So I could put those in, weld it and array it. But that's all we're going to do for our little roundabout. We'll move on to something else in a second.
Okay, so that is the roundabout section. The last bit we're going to look at, I thought I could get a lot more done, but an hour is not a huge amount of time, so I might do another webinar next quarter. We'll do a few other bits and pieces. The next one we're going to look at is railing. So most parks have railings like this, and I know you would most of the time buy these in panels, but again, I'm just going to show you some different modeling tips and tricks for setting up custom connections. So because there's no top rail in these rails, we can't use the standard macro because that running rail is broken between the posts. The standard macro, the top rail is continuous. So we're going to model them manually. So I'm going to use commands like split beam to make the modeling easier. And then where the connections, where we've got the little vertical drop down to the post, if you guys have connections that you're manually creating over lots and lots of different projects, you could create those as custom connections. So a lot of this last bit of the webinar is going to be looking at custom connections and a couple of beam commands. Okay, so I have just finished off our little roundabout. I've put the handles on here and then I've rotated the special parts around. So the last little bit we're going to look at today is the railing. So as shown in the PowerPoint, I want to do railings with no top rail with the hoops on. So the out of the box railing macro won't allow you to do that. You need a top rail on there. So by the time you set the macro up and then exploded it and deleted the top rail and deleted the welds, myself and Alec looked at this a couple of days ago and we think it's probably quicker just to create these railings from scratch. But we can create the connections with custom connections and do a couple of things. So that's what we're gonna look at in here. So I'm gonna start with a box section post and we'll put this, we'll just do sort of 4 or 5 panels. We'll make this 1100. 50 by 30 by 3.2 is fine, not quite sure. We don't want timber. And we'll just put painted for now. And we'll rotate that 90 degrees. And what we'll do to match the railing macro for the model rolls, we'll call this railing. We'll scroll down and we'll have a look. We'll call it railing post landing, because that's what the macro would call it. And we'll copy that. Just keep it nice and simple. We'll just put 5 posts in, so 4 panels. Now we're going to do the flat bars. Now what I am going to do is I'm going to do those flat bars in 1 length. And we're going to make those 40 by 8. Not quite 40 by 8. And we're going to rotate those. Just check the system line positioning. That's going to do that. That's going to go to the top. So that's what I want. I'm actually going to put these on the railings layer. And then that needs moving down, let's say 150 mil. And then I'm going to copy those down to about there. here, so we'll do 870. We'll do 900. Now what I need to do is, that's obviously one continuous length. So in Advanced Steel, there is a split beam command, which I'm just looking for here. So that's merge beams, this one above it, split beams. So that is splitting beams at a certain point. So I'm going to go back to just having my node point on. So if we do, it's these two beams we want to split on that point, and that point. And then there's my different split. Now what I'm going to do is I'm going to have a little drop down plate in here. So we're going to build that as a custom connection. So the first thing I need to do is bring these beams back. So I'm going to use cut object because that will make it intelligent. So we can say the section to cut against is this one, the section to cut is that one. Now I'm not going to weld it because I don't want it welded to the post, but I am going to bring it back a millimeter. Yeah, we'll go 2 mil. And now what we need to do is we're going to do a drop down tab plate, I think. So what we're going to do is we're going to use the custom connections tab. Now, so in the custom connection tab, I'm going to use these building bricks in here. Now we have a flat bar, and you'll see these commands are plate along beam flange, plate on beam flange, or plate parallel to beam flange. In the flat bar, you need to figure out what is the flange. So the flange is either sides, and then so we're looking for a building brick that will put a plate parallel to the beam web. So we'll start with this one. Do I want to select a reference point? No. Now what we can do in here is we can say put it on the main physical, so the physical end of the beam, and we'll do perpendicular, and we'll say the other side. And this is where I'm going to say create a weld. So it's going to be 8 mil thick. And the height, I don't know, 50, 60 maybe, 60 will do. And that's all I need to do. Now, the beauty of this is, if I now change this to a bigger section size, it'll need updating, but that plate will now always go to the physical end of the beam. So will the cut. So we can use this connection on different beams. Now I'm going to copy that to the beam there. Now that might have gone, because I haven't done a cut object, so that's not going to do what I want. That's why it's not doing it. So the section to cut against is this one, the section to cut is that one, and then we'll just have to go in and update that plate. So we'll just so we need to go just redo it to the main physical. Now because each end of the system has two ends of a beam, they will behave differently. So when you're doing these custom connections, it is important to try and create all of the beams in the same way, all of the posts in the same way. Otherwise you might find your custom connections behave a little bit differently. Alec has done a webinar on custom connections, and that can be found in the content portal, so that's not going to be going to the right place. And then we can joint copy this one. Now the reason I'm doing this is because obviously I've got different ends and things like that. And then within our custom connection, we can also do a bolts, anchors, holes on a plate. So that's our plate. That's the beam in there. That puts too many in, but we can just say, right, it's 1 and 1 based on the center point. And then we can come in here and change that. Let's just say we're going to go for a 10 mil XOX. And then in here, we're going to do the same. But we're gonna do a single and a double connection. So that's the plate, it's connected to that. I needed to do both at the same time. So that's the plate, it's connected to that and that as well. 1 and 1.
And then in the bolt here, I can don't do finish calculation at gap because it's finding the gap in the box section. And again, we'll just make that an M10. Now, if we were doing these sorts of things and we were repeating them all the time, I wouldn't want to copy these around. I want to do them as a custom connection, but I want to do something else as a custom connection as well. I actually want to do the railings, and in fact, while I'm on the cap plate, I also want to do the cap plate as a custom connection. So, well, not a custom connection, but a connection, but I want to roll lots of things into the custom connection. So I'm going to just do the end plate that we did earlier on. And again, we'll make that 5mm thick. We'll shorten the post by the plate thickness. And we'll just say it's a 6mm fillet weld all around. And then we'll joint copy that to the top of that post. So the one I was going to look at is the sort of looped bars. Now again, I talked earlier on about modeling things, how you're going to make them. So I'm going to, let's just bring that over 150, and then we'll come back 50 there. We'll drop this all the way down. Now I want to go down in the Y point, so I don't want to go down to there, I want to drop it down in the Y. So if I do this .Y command, that says the X and Z is set to 0. What's my Y point? So I can click that point there, and that will give me that. We'll extend that another 50, and we'll copy this from the endpoint to the endpoint. Now if I do a fillet, should be able to put a 50mm radius between these two, and then I should be able to join all of these together. Maybe I should have done that as a 3-point arc, but as long as when I go into my properties that's a polyline, that's absolutely fine. Make sure I turn that 2D lock back off, and then I'm going to do beam from polyline. Now like I said, this is model it how you're going to make it. So for me, that's going to go into our pipe bending machine or our bending machine. So that is going to be as a poly beam. If you were doing 2 flat bars and welding it, then model it that way. Do we want to delete that afterwards? Yes. Now it's trying to do it as a box section because that was the last beam I modelled. So we'll do it as a 10mm round bar. That's fine. We do want to give it a name. So we'll call it curved beam because it is a curved beam. That's all fine. And what I'm going to do in here, just in case this bottom bit moves, I am going to do a cutter object. So I'm going to say section to cut against is that, section to cut is that one, and then I'm going to create the weld because the weld goes in on the bottom piece. So what we'll do now, we'll come to the top. Now, depending on what you do here will depend on, again, how you're going to model things. So we need to put some holes in here for this to run through. Are they going to be drilled or are they going to be plasma cut? Or are they going to be contours? So if they're going to be drilled, and remember this is a flat bar, so we're running an NC file for this. If they're going to be drilled, we would use a hole by toggling our switch here. If they were going to be done with like a laser profile and you want to contour, we would use a circular contour based on a center point. So again, just find out from the workshop how they're making it, because holes and contours are displayed in different ways in NC file. So I'm going to do mine as holes. So we're going to put our center point in at 150. I'm then going to say, right, put 2 holes in there based on the center point, which is that one. And I'm going to say it's, and it will have put it in down there because I haven't moved my UCS, and everything in Advanced Steel is driven by the UCS. So we'll just put that back, choose the endpoint,
They are going to be maybe diameter 11 or 10.5. Just allow that to pass through, and we want those at 100 centers. So now that we have everything that we want to do, we'll save this file, but I'm going to copy these items into my custom connection file. So I'm going to start a new template. And we'll just paste these items in, and then we'll turn all of this into a custom connection, and then we'll see how we get on. So the custom connection will work. We need to turn the join box on in here. So the custom connections, I can get it to put that cap on and that piece in there. So what we'll do is we'll go to the custom connections tab and say create connection template. And this is going to be based on 2 beams. So the first one is going to be the post. The second one is going to be the top rail. And we will call this left hand single post to, I call them running rails, to running rail. Then in here we'll say select post, and in here we'll say top running rail. And then we just say, right, I want you to put all of those items on. So we'll copy that. And then we'll do another one. And we'll say this time it's 3 beams. So it's post, left hand rail, right hand rail. And we'll call this double post. That's going to be post, left top rail, and right top rail. Get my capitals, and then what do we want it to put on? We want it to put all of that on. Now what we should do before we actually go and do this is do our checks on it. So it's found no errors on the clash check. We also want to make sure that things aren't welded up, so the cap plate is welded to the post. These lugs are welded to the rails. And then what we'll do is we'll try and put this one in as a custom connection as well. So we'll say this is based on 2 beams, so it's top running rail, bottom running rail, and we'll put bent or hooped infill bar. Infill bar, top running rail. I've called them top rails and top running rails, but I will say bottom running rail, but you get the idea. And then what do we want it to put in? Well, I want it to put that in, I want it to put the holes in, and I want it to put the welds in at the bottom here. Now I might want to put in, let's see, if we say show me what's attached to the workshop there. Now nothing is actually, you see that isn't attaching that because I haven't put the weld in, so we'll say that and that based on the endpoint in there, and that'll just put me a little weld in there. And then I can say, right, I want to just reselect what you're going to put in, because I want you to put the holes, the weld, cutter object at the bottom. So I'm just changing that. Now to get this to work, you need to save this in a particular location on your C drive. So it's the for me, I'm working in the Advanced Steel GBR. So we go Program Data, Autodesk, Advanced Steel 2021, GBR, Shared, Connection Templates. Now if we were a company that did play park railings all the time, we'll just call it railings because this could be used in anything. I can close that down. If I come back to this file, I can actually take off everything I've just done there because I don't need that anymore. We'll go back to a realistic view. I'm conscious we are running out of time. And now I'll say insert a connection template. Now what that will do is that will go and look in that folder, and now I've got the railings file. So I've got the left-hand single post running rail. So select the post, select the top running rail, and that will put all of that and the cap plate on. For the other one, we can do the double post running rail. So select the post, select the left top rail, select the right top rail, and then hopefully with a little bit of luck we can then say hooped infill bar, top running rail, bottom running rail. That will put that in, and then we have something that we can say, right, we want to copy that 200 mil in the X direction, and we want, let's say 3, maybe 4. Do a preview on that. Okay, so we'll modify what it's selecting. So we'll say the custom connection and that, please. Include additional connections, do a preview. What am I missing here? Let's say copy that then. Do a preview. Okay, so we want, in this example, we probably want one less, and then we might have to recenter them. But that is how I would go about doing that. Well, that's one way of doing it with custom connections. Okay, so that I am slightly running over. That takes us to the end of today's webinar. Hopefully you found some, although I don't think many of you are doing play parts using advanced steel, hopefully it's shown you a couple of different modeling tips and tricks that you can take away from today's webinar. If anyone does have any questions, type them in the question box or just reach out to me over email or my LinkedIn account. So I'll keep the session running for about 3 or 4 more minutes to give people time to type in any questions. And if you don't have any, thank you very much for joining today's webinar. Okay, so I haven't had any questions come in on what we've shown today. So we will end the webinar there. Thank you very much for joining today, and we'll hopefully see you on the next couple of Advanced Steel webinars.